The answer to the question what operating system and why we are using Linux is the next. It's top 500 ARC, and we have 100% of Linux operating system family. Yes, if you are looking here, operating system, submit, you will have some different distributions, but all these distributions are very close by the principles. They use the same kernel and principles of how to work with them. So this is the ideas. Okay, what we will do today, we will talk about few theoretical ideas. So you have to understand the whole roadmap. If you need to write parallel program, what you have to do. If you have task, how you can resolve this task. So in this part of our conversation, we'll talk about this. About Linux, we want to know how to get IP address, how to check network availability, your directories, files, copy, move, create, remove, and link. The most important, because it's important to code edit. Also we talked about compilation, but today we continue not only simple using GCC, but today we will start also OpenMP. I believe it will be possible. And also how to install new program installation. We'll talk about it. About program installation, we will talk about apt system. And if you look in my other screen, I show you this screen. We did before apt-get update, and now I'm doing, while we will talk about, we also upgrade our system. We also will upgrade packages in our system and upgrade our system. It will take some time. Yes, you see it needs to take some megabytes. I'll explain you these commands. So now you have to understand that we have command 1 is that's for future explanation. It's apt-get update, apt-get dist-upgrade. I will explain you what is the ideas, and in a short, it's something like PlayMarket for Linux. That's it will be in. It's for simplicity. It's not good explanation, but that's like some central place from which you can install any of your program and check for signature of it, and it is safe, fast and simple. And OpenMP, we will start with it. Only start with OpenMP. So this is our roadmap, and let's move forward. Also in the background you see that I'm updating my operating system. It takes some time, so I believe that while I'm explaining some theoretical tasks, ideas, you will continue. Also what you will do, I want you in your computers, please do the next, because you also have virtual machine. So please do the next. In the command line prompt in the terminal, type this, and then after this command finished, finishes. It also asks you for the password. It's for your password. And also after it, run this command. These two commands. Later I'll explain you. This command will be executed in rather small amount of time, but this command may take more time. You see here it's only downloaded. Downloading takes about 70, maybe 20 minutes. Also will have installation and etc. So let's move to our resource. I suggested you in our previous class to look at this resource, and here we have some classifications. In a short, we talked about classifications of the systems, high performance computer systems. We classify them. We classify them by memory architectures. We have shared memory, distributed memory, and hybrid distributed shared memory. Also, we can talk about, and we will talk about them today, it's about parallel programming models. That's about concepts. And then how to design parallel programs. And also there are some examples we can talk about and try to explain them. So in our previous class, okay, at first maybe models. So model of shared memory. Shared memory on the distributed memory machine. So you have physical distributed memory, but you have some whole shared memory. Also we have physically shared memory, and we have distributed memory model. That's a bit different approach. Also we have shared memory model without threads, and we also have the same model with the threads. What I mean that you have some address space, and this address space used by multiple processes, yes, and then write to this memory, and then they can read from this memory. How it looks like in a Linux? In a Linux we have something which called shared memory, and we have special commands. At first, process. When we are talking about the process, we are talking about programs or tasks, yes. And we have multiple different commands in Linux to manage shared memory. We can read about it. Let's do. We talked about it. If we ask help, yes, we can find out multiple different explanations what we have, what we can work, how we can work with the shared memory. let's look here, because we have multiple different memory allocations. So we can ask in this way. Chat. Oh, let it be this overview. Good. So to explain you from practical point of view, we open man 7 shared memory overview. So the first we have the POSIX shared memory API allows process to communicate information by sharing a region of memory. So you have random memory, yes, you have some memory, and you select this region from the memory and share this memory between few processes, and other processes are not allowed to read and write to this memory. So at first you have allocate this memory, then you have what options do you have, what you can do with this memory. You have at first create and open new object, because memory is not something abstract, you create some object in the memory. You can set the size of this memory object. Then you can map shared memory object into virtual address space. Then you can nmap it, unlink it when you use it, close it also. Some start structure to get information about, and also we can change own and permission to this shared memory object. So you're working like with a file. That's something like file. Open file, yes, set size of the file, except maybe map function is not here, but unlink, close, statistics, change own, change mode, the same commands are available. So these are everything about shared memory. Also here we see that we also have something, what is SAM overview. Let's also look at SAM overview. What is SAM? So we have two manual pages here. POSIX semaphores allow processes and threads to synchronize their actions. Because if you have multiple threads, in previous hour class I explained you that if you have one whiteboard or blackboard and every student comes with a chalk to this board, write something, you will have something unpredictable in this whiteboard. You have to set some rules how many students can write in the board and at one moment. So one of the ways to do this is semaphores, using of semaphores. Now you can look at this, and you SAM close, SAM destroys, SAM get value, SAM init, SAM open, set post, and etc. These all are functions working with the shared memory. So it's real functions, because SAM close 3 is real function. Let me show you as example. You see include, semaphore, and etc. You will use with the threads. So what we are talking about? We are talking about this concept, and if you have multiple threads, this task becomes more complicated. But all of these tools you have, and they are available for you as a developer. So we have something, what is POSIX threads, and you have to distinguish two ideas. So at first I want to explain you a few ideas, and you have to distinguish idea of process and idea of a thread. What is the difference between them? At first, process, it's like a program. it has own memory address space. And this is the program indeed. Like a program, it's a program. It's a program. And then can have multiple threads also inside the process. One or multiple. Can have, may not have, maybe may. The next what we'll have the next, multiple, may have multiple threads. Own memory may have multiple threads, and also that's maybe also own file descriptors of open files. And open sockets. So these all are that means could be network connection, to database. And now what about thread? Thread is a part of the program or process, has own stack, share memory with other threads, share file descriptors, and also share open sockets. And there are additional differences, but these are the main differences. And for your point of view, in my opinion maybe, but in some cases it's not a good option, but sometimes it's the simplest way to provide concurrency. Also, new word, concurrency. You have to distinguish and understand that concurrency is not the same as a parallel. That means that you have multiple threads which execute at the same time, or maybe with some small shifting of the time. But in general, they executing like in this at the same time. So this is concurrency. Sometimes it looks like parallel, sometimes. So sometimes it's these concepts are the same. This is the idea of process, and this is the idea of thread. Thread is simply concurrency for developer. because in this case you handle only you're working because so this is important. This is important. This is important, and you have to understand this. So this is the idea and concepts: process, thread, concurrency. In this way, in this case, you have to handle this by the commands I shown before. So the idea of concurrency and the process. Okay, let's move forward, and we have another models. We have distributed memory. In this model, we have one machine, another machine. We have memory in one machine, in other machine, and we have to provide connection between them. In our course, we will use message pass interface to provide this. It will be later, but we will use this. Also, we have data parallel model or partitioned global address space model. So we have address space is treated globally. Most of the parallel work focuses on performing operations on a data set. The data set is typically organized in a common structure such as array or cube. A set of tasks work collectively on the same data structure. However, each task works on a different partition of the same data structure. Tasks perform the same operation on their partition of work. For example, add 4 to every array element. Yes? So you get idea. Got idea. On shared memory architectures, all tasks may have access to the data structures through global memory. On distributed memory structures, the global data structure can be split up logically and or physically across tasks. We have some implementations, but indeed in our course we will not talk about this, and we will not work with this model. It's complicated, rather complicated model. And there are a few implementations, we will not work with them. Another technology is hybrid model, which combines technologies like MPI and OpenMP. It's shared memory and distributed memory. So we'll combine shared memory and distributed memory, and also GPU could be combined here. So this is the ideas. So CPU, GPU, and all of this we will learn how to work with them. SPMD and MPMD, single program multiple data. And multiple program multiple data. Yes, we this is the model we are working. I talked about them previously. So we have multiple vector processors. They are working. They work in this way. Also, we have multiple program and multiple data. They are represented here. And usually clusters, OpenMP and MPI are the systems which implement this concept. Also, we have automatic and manual parallelization, but in our course we will use manual parallelization. We'll do it manually in a programmatic way. So you are doing it in programmer as a programmer directed. So we have few ideas how to work and how to write our program, but the first idea is domain decomposition, how to decompose our task into simplest task, and how you can parallelize your task and provide equal portion of a task for each thread or each process. It depends on the technology you're using. We have also functional decomposition, because we have domain decomposition, yes, some data set. You have functional decomposition, where you take different functions for different threads. These are two main ideas how you can decompose your tasks. And also these are the tasks, examples of them. So let's be more closer to our ideas, and let's talk about this briefly, and then let's make short summary on this. That if we are talking about distributed memory, or maybe I will draw for you a small image, it will be better. If you draw a small image, it will be better to understand. What do we have? We have, at first, let's classify our system. We have systems, and we name them as distributed memory. Yes, that's models. That will be models. We have shared memory. We have also, let me add additional. It will be GPU. It means graphical. Okay, I will write it here, or maybe here at this position. GPU means graphical processor for general purpose processor unit. Let's like this. And also we have hybrid, which combines all of these technologies. And now few ideas about them. Hybrid, GPU, shared memory. So these are the models or ideas. And now let's talk about what we'll talk about. We'll talk about what you have to know. It's everything about hardware. It's everything about hardware, and it's about software. If you're talking about hardware and software, what we can do? We are talking about. Okay, first about clusters. We are talking about clusters and MPP systems. So this about hardware. Clusters and MPP. That's architectures. Here we are talking about multi-core CPU, multi-CPU, Also close to this is a concept of SMP. Symmetric multiprocessing. Symmetric multiprocessing. SMP. And also, if we are talking about different shortening, we'll talk about that MPP means massive. Indeed, it's like clusters, only clusters with some specific communication interfaces. So now you see the whole picture about this. Yes, if you're talking about this here, about GPU, we are talking about video cards and computational accelerators. That's like something like Tesla, from NVIDIA Tesla, and etc. So these are technologies which are very close to this, to them. Video cards, computational accelerators, NVIDIA Tesla. And about hybrid. What about hybrid? That's when you combine together clusters clusters of multi-core CPU equipped with GPU, or not equipped or not equipped, depends on, but clusters of multi-core CPU, these are the hybrid. That's how look like this. And now what about technologies which we will use in this course and which you can use at all? At first we will start from this here. Shared memory, you can use POSIX threads or threads, different thread libraries. That's common technologies which usually used in operating systems. In our course we will talk about technology OpenMP. We'll start to talk about this technology today, OpenMP. These are programming techniques. If you're talking about distributed memory, what it could be? It could be sockets, network sockets. We will not cover this topic in our course because it's more about closer to ordinary programming. Network sockets, we are talking TCP, UDP sockets, or etc. Also we can talk about remote procedure call, or RPC. In some technologies it's something like RMI, sometimes it could be Corba, JAX, RPC, or etc. But these are technologies which are used commonly. But in our course we will talk about message passing interface. or briefly MPI, abbreviation of this technology. So that's about technologies which we are using with distributed memory. If we're talking about GPU, we are talking about NVIDIA CUDA, which means compute unified device architecture. And also we'll talk about opencl, Open Computational Language. About NVIDIA, we will talk about from NVIDIA OpenACC. OpenCL, that's about, you saw that we have NVIDIA, yes? Here we can talk about any vendor, not vendor locked. So in NVIDIA, in Intel, in AMD video cards, you can write your code with this. And about hybrid, that's when you're mixing CUDA, OpenCL, OpenMP, MPI, so we are mixing these technologies. That's different mixes of them. For instance, OpenMP plus MPI, CUDA plus MPI, and etc. OpenMP, it depends on the domain and task you are resolving, plus for instance CUDA, and etc. Other combinations, maybe 3 of these technologies. So the main ideas I explain you in this picture. So the whole idea, and what we'll talk about in our course, we'll talk about the clusters, about hardware. We'll talk about multi-core and multi-CPU. The ideas are the same. We'll talk about video cards, computational accelerators, and we will talk about OpenCL technology, and we will talk about NVIDIA CUDA. We will talk about OpenMP, and we will talk about MPI. So we will not mix these technologies, we will use them separately, but you will be acknowledged how to use and how to work with these technologies. So this is the whole map for you, how to write your programs, what technologies you will know, after acknowledge what technology you will be acknowledged, with what technologies you will be acknowledged after our course, and what programs you will write. For all of our programs, it will be enough to know C or C++. Also, with all of these technologies, we can use Fortran. But we will build cluster. In our class, this class, we configuring one computer, yes, but for the next classes, when we'll talk about MPI, we'll build cluster. Computer of 2 nodes. So for now, we see that something goes wrong here. I understand what going wrong, but according to our roadmap, that's all about some theoretical part. And now we move to Linux, and now move to working with our environment. In Linux operating system, we are using something very close to which I wrote for you here, something like PlayMarket or Apple Store or Play Store, something like this, because we have some central repositories which allows you to install all the packages you need. When we go here and we have system tools like Synaptic Package Manager, ask my password because it needs administrator's rights. I have categories. I have the categories, and I can install packages from these categories: databases, development, all these categories. I can choose which one I prefer. Also, we have here in this, we have repositories. Repositories are the places where from we will install our packages. And we can choose different locations of our repositories, because usually these are mirrors of the same packages, and you may find out the closest to you, which one is closest to you, and choose this one. In this case, you will have ability to install your servers faster, so software faster. You saw that I have United States now, but you can choose another option, and you see that that when I click select best server, I found Ubuntu Volia.net. It's Ukrainian provider, and you see that it's from Ukraine. So I click here, choose server, and now I have ability to download from this server. I can also choose which one, which packages I want to install. Also canonical partners. If need source code, you can add repository, any repository you prefer. For instance, you know, okay, let's okay, what it could be, what repositories it could be. In our course, I tell you that we have Java, yes, JDK, bellstop, for instance, bellstop JDK, not Docker, but simply JDK we want to install, bellstop JDK, Java, because we also learn in Java. Download, yes, and here we have, if you look here, we see that we have Linux repositories, and we have apt. We go here, click here, and we see private repository of this company, and what we can do, we can add this repository. Here we see how we can do this. You can do it manually, like here. So you go into your command line prompt, sorry, not this, but go here. In the Linux command line prompt, what you are doing this. Let's do add repository, yes, apt line, and you have to add this. But before adding this, we will do the next. We will go to the command line prompt and paste here information we sure, yes, we can, yes, because you are from Ukraine, it will be faster. It will not take some too much time if you download everything from. So what I'm doing now. So yes, you choose it. And simply I show you what I'm doing now. Sorry, not this window, here. I paste here this line of the code, my password again, so I see the message OK. What the meaning of this line? It means that we trust this source, the source of this code. That means that we trust the source, this source. I did it in command line prompt. But also what I do, I copy this line copy this line here and put it here, apt line, this. You see that something like the line above. So add source, and now we also have this this repository. Also we have updates here. Authentication if it needed. Oh, you see, we can add import key file here. We also put this file here. It's possible to do also. Additional drivers if needed, developer options. So what we do, so now I click close and a repository is changed. The repository information has changed. You have to click on the reload, and now reload, I click on reload, and you see repository will be checked for new, removed or upgraded software packages. What I click here is the same like I'm typing in a command line prompt this command. These things are the same. In command line prompt you simply can type this and it will be the same like update information about packages. What does it mean? It means that you have your computer where we install Linux, where we installed Linux, it is already installed, and we synchronize information about programs in our computer with information about the programs which are available in this server. For instance, in Ubuntu Volia.net. So we synchronize this information. If you extend this window, you will see that it downloads different. That's only information. It's not really packages. It's only information about packages. You have to distinguish these two principles. So I'm doing these updates. I'm still waiting. Okay, there are few close. Okay, let's look at this. And now what we can do now? Let's try to install JDK. We previously name bellstop. Let's look for it. No, we don't have anything. Name, description, name, search. Oh, we just added this JDK, and okay, default JDK, Ubuntu JDK, but we need strange. Where is this repository? I added just now. We have to have this here. Standard. OpenJDK. Just a moment, maybe it's Liberica. No. Okay, and again JDK. No, we don't have anything. Architecture. Okay, and again settings, repositories, package. Okay, let's do this from command line prompt again. sudo apt-get update. Release file for is not valid yet, invalid for another. Okay, updates from the repository. Updates for this repository will not be applied. Release for this. Sorry. Let's check for the time. We have 1st of March. Oh, the issue with the time. Okay, today we have what day we have today? We have today 22 of March. Yes. So that's evident why we have this issue. Yes, right, Rahim. It is the time, the issue with the time. So we will let's do it properly. For this purpose, we will first, what we will do, we have command with the name date. It only shows for us the time, 1st of March. Now we can do what we can do. We can set. Let's check. Okay, show UTC. Let's check. Yes, we have this time now. Yes, and what we have to do now, we set date. We have today 22 of March. Then we have 1, and we have, let it be in this way. Sorry, sudo. We updated the time, and now we have to synchronize hardware time synchronize sorry, to HC. So from command line prompt, now we updated the time. How to do this? To do this, we simply set this command date, but with sudo we update the time. So in our notes, I add additional command. It is how to set time. Yes, we set the time, and now I'm doing apt-get repositories, the command we did before. Let's check, and now everything okay. You see, yes, everything is fine. The next command is sudo apt-get dist-upgrade, and this command want to download too much files. You simply type Y capital, and we have to wait some time. It's not too much time because we are using our Ukrainian provider, and you see that the issue was with the date, inappropriate date. So we install, we update all our packages in our system. we update them. While it's updating, we can talk about other needed commands for you. Okay, let's move forward to this step. While it's updating, and also I show you how to install package, sudo apt-get install, and the name of package you need. In our case it will be, for instance, bellstop, but we will check the name of this package and see. So you will know how to do it from command line prompt and from graphical user interface. So the question, how to get your IP address and check network availability. How to do this? At first we have command IPA. Let's try to do this. I open additional tab. Maybe just a moment, file, new tab, IPA, and now you will see that you have two IP addresses. First of all, you have loopback. It's your local address which is not visible from internet outside your computer. That's only for testing purposes, and you can test your network application with this IP address. And also we have network interface card with this address. This address will be different in your case. It will be your IP address which was given to you by your router. So this is your IP address. How you can check that network is available? At first, the previous command here cannot execute properly without connection, network connection. But to test that you have your network connection, you simply type ping 888. In this case, you test your connection to Google DNS name server. Also, you can ping google.com. That's ping, command ping. If something goes wrong, you will see some errors. Also, we have command mtr, which allows you to trace packages, and you can see the whole road, for instance gmail.com, and you will see how your package is transmitted through the internet, and you can see how it looks like in my case, what IP addresses are used, how data transmitted, and this is very useful command. My trace road, mtr, how it looks like, mtr and the name of the site, or sorry, not site, server, the server, in this case it's server, or IP address, any IP address you need to test. So two commands to test that you can connect. Okay, while it's downloading, we move forward. So we have two commands, IPA, we have ping IP address, for instance 888 or something else, ping gmail.com, mtr gmail.com. That's for testing. You have to know and check network availability. These two things allows you to test network is correctly works or not. The next, what about directories, files, copy, create, remove, link, and etc. At first, all of these operations you can do with the graphical user interface. But if it's not available and you don't want to do it in graphical user interface, you can do it from command line interface. So at first, where you are. To test where you are, print working directory. Print working directory. It's a shorten. Print pwd. The next, I'm at a home student. I want to create directory. mkdir, make directory. ISE3, make directory, ISE2. The next, I want to list I have these directories or not. I type command ls, and I see other directories which are available in this folder. Also, you can do this, yes, graphical user interface, and do it with a clicking right click folder, and you see that we just created these two folders. We just created them. Don't click here. Remind me later, because at this stage we are updating system from command line prompt, so we cannot do it from two places. So to make directory, we are doing mk directory. Print working directory shows you why you here at home directory. If you need to add into ISE2, you can do it in this way: cd a number of directory, or you can type the whole path cd home student ISE3, and we have the whole path. It's called absolute path to your directory. This is absolute path. Also, what you can do, you can use not absolute path, you can use something like this, ISE2. In this case, oh sorry, not this, but cd ISE2. In this case, what you are doing, what means two dots? Two dots means that you are going up into directory. So now I'm in a home student, I go to ISE2, yes, but I want to go up, cd space two dots, cd space two dots, up and level up. We are in a root. I cannot go up because it's the higher point of our file system. So we can type how many times. If you want to go in a faster way to your home directory, you can simply type cd, and you will automatically you will be at your home directory. So now you are at your home student directory. So that's how it looks like. The next. What is the next? So how to change directory, you know. So we go to ISE3, make directory, for instance Java, make directory Java, make directory parallel computations, yes, and we have two directories now. To see extended information, ls-l. Then we have the owner of this file, the group of the owners, and the size and date of creation. And also we have these flags which show you what is this file. What? Let me explain what does it mean. Okay, what I will do, I explain you what is the structure of this file. We have this. At the first position we have D, means directory. It could be directory. It could be also minus, it's a regular file. It also could be link, symbolic link. It will be dirty comparison, but it's like a shortcut in Windows. Very dirty. More closer to say that in Windows you also have links, but you didn't use it before because maybe you don't know what is the links. Symbolic links are also available in Windows. Symbolic link in Windows. They are also available. S is a socket, Unix socket. We will not work with them, but you have to understand what does it mean. We also have P. That means that this is pipe, Unix pipe. So yes, there are also additional, that means character device. Also we have block device, but we will talk in our course maybe about these three of them. Maybe also I will tell you a few words about them, but not now, but I will tell you about them. Also, what about the next? We have this one, yes, we talked about it, and now we have this. We have three of these and three of these. So we have 10 flags. First of all, R means read, W means write, X means execute. We have three groups. First of all, first three, yes, first of them are owner, rights of owner. First three, owner rights. Second three, group rights. And third three are the others rights. That's all. If you have minus, that means that rules are not allowed. So that means that others can only read and execute, but cannot write. Group can read, write, and execute. And important notice, in Unix, file extension is only for information purposes. Okay, so now you know and understand what does it mean. The next, we talked about how to create directory, what are the files. Okay, how to create file. To create empty file, we have to use command with the name touch and the name of our file, file.c. Now if you look here, we will see that we created empty file. The size of this file is 0. You can edit this file. At the beginning, what we will do, we can do it with graphical user interface and editor. In a command line prompt, we have also editors, and in previous our class, it's installing, we installed also Midnight Commander file manager. It's a file manager. You can find out this file. We also have here ability to create directory, delete file, edit file. We can edit file, click here to edit, and then we can edit it with choose 3, version 3 is mcedit. It will be the simplest way. And now you have ability to type your code. Maybe it's a bit ugly, but no, you can use it. Now so we have ability to write our programs. Save. and quit. So now I have the file. With this button I can view it, quit. So I can view and work with the files. If you are talking about command line prompt, okay, let it be in this way. It will be enough for us at the beginning. Later I will explain you additional commands like cat and etc. But today it will be enough for you. You can create your file, edit it in this way. How to copy file? To copy file we use command cp, and we have file.c, and we can copy it into PC. Now if we check directory PC, we will see that we have also file here with the same size and the same file. And what we can do also, we can move file. We can move file C into directory, for instance Java. Yes. Now we will not have file in the directory current directory, but we will have file in the directory Java. So you see we have these files. So mv move. If you want to remove file, we are using command rm java.c. We remove this file. You see the total is 0. So create, list, remove, and edit. All these needed commands I provide for you. And what about link? Okay, let's look in this idea. The idea of a link in Linux is behind the it's like a shortcut in Windows. But what does it mean? It allows you to create symbolic or hard link. What does it mean? It means that you have, okay, let's create additional let's copy file C again, or let's do the next. Let's create ln -s. Ln means link, and new file.c. So you see I have new file.c, but in command line prompt I see that it's pointing, and you see that it's starting with the L. It's pointing into this file. Important idea, if you edit this file or this file, you're editing, in this case, you're editing the same file. You are editing the same file. So this allows you to work with the same file from different places if it's needed. So this is the idea of links, symbolic links. So that's about symbolic links. Also there are hard links, but in this case hard link will not be highlighted like in this way, but I will not explain you now what is the purpose, but you can create your hard link in this way: ln file.c file2.c. Interesting idea that you see that the size, let's compare to size, okay, and ln-s file.c, and the name of the symbolic link, file symbolic. Okay, now I created hard link and symbolic link, and also we have ordinary file. Let's compare them. You see that this file has 6 bytes. This symbolic, okay, this was original file. This is hard link, and this is symbolic link. Symbolic links has the size only which depends on the name. That's the whole idea. The only it contains only the link to this file. And if you remove file.c and look again, you will see that we still have file simp.c, which pointed into file.c, but the file is not available. If you try to, okay, another command, okay, let's do it also, command to view file, which allows you to view file, cat file minus file.c. No such file. Yes, we see we removed the file. But let's look this file, file minus smbc, no such file or directory. But if you look into hard link, because file2.c is a hard link, we have the same information. So hard link, it's a link into data structures in your hard drive, in your file system, sorry, to be more precise. It's a special link into data structures in your file system, but a symbolic link is only link into the path of this file, into the absolute path to this file. So this is the idea, not only absolute, but it also could be not absolute path. So you get the idea what I'm bringing for you. So links are like some shortcuts, but hard link is more systematic, system dependent, file system dependent. Yes, but indeed in your file system you are not storing copy of this file, it's only link. And now you can restore your file, ln file 2.c file.c. You restore this file, and now you look here and everything fine. Now you can look cat file, and you see the contents of this file. You can look file.c, and you see the contents. So this is the idea of a link. How to edit code I also show you. How to compile program. Okay, and now it's still installing, but we can compile our program. So the simplest way to compile program I showed you before, but I'll do it now also. It's use compiler GCC, which we installed in previous our class. And the next, we are putting option, we are using file, the name of this file. And if you do not provide any additional parameters to compiler, you will obtain file with the name out. If you want to run this program, you simply type /a.out, the name of this file, and you will see the message. If you want to set another name, a bit different name, of not this, myprogram.run, I put -o and the name of this program. File.c. Yes, sorry. Now that's also be my program, and I can run it. Also, we can use additional parameters of our file in our file. Let's do again mcedit file.c, and I put here, I shown you before, include math age. And what we'll do here, we print f and that what we'll put, we put here, for instance, 0.3, and then and then 0.3. Then we save. And also let's put here this save. We save it. And you saw that Midnight Commander saw that we have hard links. We quit. Let's compile our program again. We compile our program, but it could be executed. But also I suggest you to use additional option with the name -lm. Sometimes it will be needed, which means use mathematical library. That's about compilation programs. Also about OpenMP. In previous hour class, I also check still installing. In previous hour class, we talked about OpenMP technology. A few words. We install it. Install mcedit file, and what we are using, we add here include OmpH, which means OpenMP. What I'm doing now, I'm typing here pragma omp parallel, and now I have parallel code. The next, I am right here, I am set thread num. I set the number of threads, for instance 8. Save. Quit. And let's compile again. But we have some error. We have to add, set thread num. Yeah, that's okay. We have to add here -f OpenMP. Okay. I'm past set. Okay. Let it be without, maybe with or without. No. Okay. Let's set here get thread num without any arguments. And let's print on the screen the number of this value. Int threads equals to this. And now we're using API, OMP API threads. Save this. We have this. Go out. Then we compile, try to compile our program again. We compile it successfully. My program. It was executed. Threads number 0. But we can do the next. Export omp form. Sorry. Sorry. Oh, sorry, and again OMP num threads. That's my mistake. I often forget what OMP num threads, and run again, and sorry, num threads capital. Run program again, and we see that our program was executed in a parallel. So 4 times this part of our code was executed. If you set 8, then we will have a bit different result. If you look into the code, so again, you have to provide this command. It's important, so I put it into our this. And how to compile our program, we have to do this command. Yes, and to run it, what we'll do, we will type // myprogram.run. And that's about how to compile and run your program with OpenMP. We will talk about it precisely in the next other class, but now you have some general idea what to do and how to do it. You saw the command ls -l print working directory touch file name cp move also this command could be used for rename. To rename, you can rename it. Remove file, delete file, we are using file name 1. Create, yes, remove, and link ln -s and file symbol 1, and hard link without s, simply without s. So the difference between hard so these are the main commands. So that's for also renaming. Move rename, that's for copy, that's to create current directory, and it's simple list files. So I believe it's rather simple, and this is remove. It's symbolic link, it's hard link. So that's I believe it will be all. That will be all for today. And what about installation of our code system? Oh, it's still installing. Okay, so the system needs to be updated. It needs some time. So, but now we finishing with our class.